Imagine you're managing the testing phase for a new banking application. After 2 weeks of rigorous work, your team finds 120 bugs. The developers get to work and fix every single one. You run a second round of testing. This time you find 0 bugs. Your manager asks if the software is ready, and you confidently guarantee it is safe. The application launches to the public. 3 days later, the system crashes. Customers are reporting that money transfers are failing entirely. You ran the tests, and the metrics were perfect. But testing is a process of reduction, not absolute proof. It is highly effective at reducing defects, but mathematically and practically impossible for testing to prove that software is 100% bug-free. This introduces the first principle of software testing. Testing shows the presence of bugs, not their absence. As this equation shows, finding no defects does not mean you have built a bug-free system. If we want to find every bug, why can't we just test every possible input? That brings us to principle 2. Exhaustive testing is impossible. Look at this pseudocode. It represents the logic required to calculate every single character combination for a simple password. Here is the time complexity for that test plotted on a graph. With even a few variables, the computation time forms an exponential curve. Running an exhaustive test on a standard application would outlast a human lifespan. Because testing infinite variables is a mathematical dead end, software engineers use specific principles to prioritize their time on the most critical and risky paths. Look at this timeline of the software development lifecycle. Notice the cost to fix bar chart running along the bottom. Finding a bug during the requirements phase costs almost nothing. If that exact same bug reaches deployment, the cost spikes to cover patches, downtime, and lost customers. Principle 3 dictates that early testing saves time and money. When you do begin testing early, you will encounter Principle 4, defect clustering. Observe this grid of 100 modules. 80% of the bugs are concentrated in a highly complex 20% of the codebase. So if you have exactly 48 hours to test a massive e-commerce launch, you rely on these rules. You abandon exhaustive testing, and you aggressively target the heavily clustered 20%, like the checkout module, to survive the launch. Over time, developers will fix the bugs your tests find. Look at this split screen. Just as pests eventually build a biological resistance to an unchanging chemical spray, running the exact same test scripts will eventually stop catching new defects. This is Principle 5, the pesticide paradox. To keep finding bugs, you must constantly write entirely new tests. Where you apply those new tests introduces Principle 6. Testing depends on context. A graphics glitch in a mobile game requires one level of scrutiny. A calculation error in a medical pacemaker requires another. The financial and physical risks dictate your testing strategy. Finally, look at this workflow. The code is written flawlessly, and the error rate hits absolute 0. But if the customer requested a food delivery app and the engineers built a movie booking app, the project is a total failure. This is Principle 7. The absence of errors fallacy. Effective testing requires constant evolution of your methods. Flawless code has 0 value if it solves the wrong problem. To lock these 7 principles into a single framework for exams or interviews, we can build a memory matrix using the acronym BIECPCA. Look at the letters populating the left column. The first 3 parallel your exam prep. B is for bugs. Passing a mock test shows your weak spots, but it doesn't guarantee a 100% on the real thing. I is for impossible. You cannot solve every question ever written in human history. E is for early. Finding your weak topics a month before the exam is cheaper than realizing it the night before. The final 4 cover your strategy. C is for cluster. Most of your mistakes will come from just a few difficult chapters. P is for pesticide. If you solve the exact same questions repeatedly, you stop learning. C is for context. Preparing for a math exam requires different tactics than preparing for an English exam. And A is for absence. Perfect handwriting will not save you if you answer the wrong prompt entirely. Applying these 7 principles ensures that your work remains focused on finding bugs early, adapting to risk, and ultimately meeting the specific needs of the customer.